Okay, now in section 5.3.13, the question states that about 14% of the population of a large country is computer illiterate. If two people are randomly selected, what is the probability that both are computer illiterate? And what is the probability at least one is computer illiterate? Now, in this problem, you are given the fact that 14% of the population of a large country is computer illiterate. So the first step is to make this percentage into a probability. So to convert a percent into a probability, we're going to remove the percent sign and then divide by 100. Or we can move the decimal place over to the left twice. So the probability that a random person in the population is computer illiterate is 0.14. Now, to answer the first question states that if two people are randomly selected, what is the probability that both are computer illiterate? So we're going to let event E be person A is computer illiterate, and then we're going to let event F be person B is computer illiterate. So the events E and F are independent because the probability of one event is not affected by the outcome of the other event. So both the probability of event E is equal to 0.14 and the probability of event F is equal to 0.14. And now, since these events are independent, you can use the multiplication rule. And what that states is that if E and F are independent, then the probability of E and F is equal to the probability of event E times the probability of event F. So here, we're going to take the value of the probability of event E, which is 0.14, and then we're going to multiply that by the probability of event F, which is 0.14, which just gives us an answer of 0.0196. Now in question B, it states, what is the probability at least one is computer illiterate? So we have to know what is the definition of at least one. Okay, the phrase at least means greater than or equal to. So you wish to know the probability that only one or both people are computer illiterate. And these events are mutually exclusive. Now, since the events that only one or both people are computer illiterate are mutually exclusive, you can use the addition rule for disjoint events to compute that at least one person is computer illiterate. So the probability of only one or both is equal to the probability of only one plus the probability of both. Now, generally, computing these probabilities is very time consuming. However, notice that the complement of at least one person is computer illiterate is neither person is computer illiterate. So you should use the complement rule to compute the probability. So instead of using the first part, we're going to use the second part. And that means that we're going to take the probability of at least one computer illiterate is equal to 1 minus the probability of neither computer illiterate. Now, what is the probability that neither of the two people are computer illiterate? Well, to find this, you first find the probability that one is not computer illiterate. And then recall that for the probability of event E, the probability of the complement of that event is 1 minus the probability of event E. So the probability that one person is not computer illiterate is the following, which is 0.86. And how do we get that? Well, we take 1 and then we subtract 0.14, which then gives us 0.86. Now, to find the probability that both are not computer illiterate, you're going to use the multiplication rule, which says that if E and F are independent events, then we can use that formula. So the probability of neither E is equal to the probability the person 1 is not E times the probability of person 2 not in event E. So we're going to take 0.86, multiply that by 0.86, which is equal to 0.7396. And then finally, what we're going to do is we're going to compute the probability that at least one person is computer illiterate. So the probability of at least one computer illiterate is taking 1 and then subtracting our result, which is 0.7396, which represents that neither are computer illiterate. So 1 minus 0.7396 gives us a result of 0.2604.